Hey, what's up, Gio? Going into our test tomorrow. Let's get ready, rocking and rolling. If you have any questions with anything, please reach out to us. And then go ahead and like the video if you like it. I'm just kidding. That's dumb dad joke humor. My bad. Anyway, let's get started here. So we're given a pattern. We've got to make a conjecture about the pattern. Well, there's a couple different things you can look at. Hey, this is going down by 19, going down by 17. Going down by 15, so you can make a conjecture that the pattern is going down by at the next odd number. So 15, subtract 49 minus 13, and you get 36. Okay. So it goes down by the next odd number. So 36, and then it would be subtract 11 and get 25. Or you can look at these and have a different conjecture. 100, 81, 64, 49 are all perfect squares. 10 squared, 9 squared, 8 squared, 7 squared. 6 times 6 is 36, and 5 times 5 is 25. So those are going to be the next two numbers in the pattern. All right. Is the conjecture below true in all cases? If not, so it's saying if two angles are acute, then the sum of their measures equals the measure of an obtuse angle. So we have two angles that are less than 90 added together, means it's equal to an obtuse angle, which would be bigger than 90, right? Is that true or false? So if you put true, that means it's true for every case. I'm going to put false, because I don't think it's true for every case. Now, a counterexample is not a sentence, folks. Counterexample is not a sentence, folks. A counterexample is not a sentence, folks. It is an example that proves the statement false. So what you would want to do is write out something. Well, I want to take two acute angles. 2 degrees and 3 degrees. And this could be any two angles. But it says the sum is going to equal the measure of an obtuse angle. So I would say 2 plus 3 is 5 degrees. Is 5 degrees an obtuse angle? Absolutely not. That's my counterexample. There are many of them you can grab. Okay? All you need is something to prove it false, not another if-then statement and stuff like that. You just need to show the example. All right. 3 through 7, we are going to use the following sentence. Every cat has 4 legs. So we're going to write a conditional statement and if-then statement. And this is where you get to be a little creative. Every cat has 4 legs. So I'm going to put if an animal is a cat, then it has 4 legs, right? You wouldn't put if every cat then has 4 legs. That doesn't make sense, right? Or if every cat has 4 legs, then what? You're not making up the then piece. You have to take the if and the then out of that sentence, right? Is that a true statement? If an animal is a cat, then it has 4 legs. I'm going to say that's false, right? There could be a 3-legged cat or a 2-legged cat, depending on situations and scenarios in life. I guess it could be a 1-legged cat for all I know. But an animal, the cat does not always have to have 4 legs. So the hypothesis, for the sake of me not writing, you have to. Remember, the hypothesis is always after the if. An animal has 4 legs. An animal is a cat. The conclusion then is after the then. Sometimes there is no then. You have to follow the if. Hypothesis is after the if. Okay? And then write the converse of the statement. The converse, right? So if we go back to, what am I doing? If we go back to these notes, right? If you're not sure what to do, right here. All right, the converse says flip the Q, right? I'm looking at this one right here. Flip the conclusion and the hypothesis. So I'm going to take the sentence that we have here and flip it around. So if it has 4 legs, then the animal is a cat. Is that true? Every 4-legged animal has to be a cat? Nope, that's false. Right? Counterexample, dog. Counterexample, lion. Counterexample, a tiger. Right? Anything that has 4 legs that's not a cat would be your counterexample. Okay? Write the inverse. Oh, shoot, I don't remember what the inverse was. Well, we would go back to 9.2 notes. Whoops. The notes. Oh, the inverse says, go back to the original and negate, right? That little tilde means negate. So we're going to not and not the hypothesis and conclusion. So the inverse would be if an animal is not a cat, then it doesn't have 4 legs. Well, that's false. If an animal is not a cat, then it doesn't have 4 legs. Well, what if it's a lion? It has 4 legs, and it's not a cat. Okay? Contrapositive says take the original sentence, not the conclusion first, and then not the hypothesis second. So if it doesn't have 4 legs, then it isn't a cat. Well, if it doesn't have 4 legs, does it necessarily mean it can't be a cat? And the answer is false. It could be a 3-legged cat, right? So all those are false statements. All right. So this is a biconditional because of if and only if. So we're going to take that out and write an if-then statement. If Mr. K is crabby, then he doesn't get enough sleep. Okay? And then the idea with the biconditional is both the conditional and the converse statement are true. So I'm going to use a different color for this one. The converse of this then would be if he doesn't get enough sleep, then Mr. K is crabby. You could have written either of the sentences for the converse, the conditional, and then the other one would be the converse. Both are true statements because it was if and only if. All right. Now let's name the property. Well, there's parentheses, and they had a dive bomb, so that's the distributive property. If A equals B, then A plus C equals B plus C. That's the addition property of equality. C, if X equals 9, then 4X minus 1 equals 4 times 9 minus 1. That's all we did is plug it in, so substitution. If 1 equals 3, and if 1's congruent to 3 and 3 is congruent to 5, 1 and 5 are congruent, that is what we call the transitive property of congruence. What? Oh, yeah, that's the congruent symbol, so it'd be property of congruence. If D equals F, then DE equals FE. Well, that's the multiplication property. property of equality. And then ST is congruent to ST. That's the reflexive property of congruence. All right, let's do some proofs quick. We have given 5x minus 3 equals 2x plus 6. We are going to prove x equals 3. So in this one, hopefully we have room. X equals 3 is what we're going to get to. All right, well, how are we going to do this? Subtract 2x. And we get 3x minus 3 equals 6. And that was the subtraction property. And then we're going to add 3. Three x equals 9. And then we're going to divide by 3. And that was division property. And then since we had this extra, well, really I guess we don't need the way we're doing it because we're not putting simplified. We can put that right there. All right, 2-column proof. Mr. Sanderson is walking in the door. He's going to get set up today. He's got a sweet jacket on too. Wait till you guys see it. All right, so we're given, in this case, AB is 3x minus 5. BC equals 4x, and AC equals 16. That's given. Well, what do we know? We know AB plus BC equals the whole length of AC, and that was the segment addition postulate. That's that concept from first trimester, part plus part equals the whole. All right, and then we're going to sub in the stuff that we know. We know 3x minus 5 plus BC, which is 4x, is equal to 16. And I don't know if we're going to have enough room or not, but that's all right. We're going to simplify and collect like terms. We're going to add 5. Divide by 7, and then we're done. We get x is equal to 3, so we'll call that division property. And then, really, if you want to put simplify here for that last step, you really can. We should have simplify everywhere, but that's it. So the only other thing is if it said prove like AB was equal to 4, then we would have to substitute the 3 in for x and show that that's equal to 4. So let us know if you have any questions.